Let's look at the workflow of an alert comes in, a lot of work happens, and it ends in either a person being able to do a fast remediation, or it ends up being a ticket for an application team to go take care of. There's a lot of dashboards and a lot of human reasoning that goes in the middle of that workflow. A lot of it is high toil work. 5 years from now, dashboards are going to be looked at as something that's like a really expensive part of the middle. And did we really need it? I don't think so. I really don't. I think that does the ticket for engineering, will that have pretty charts, pretty graphs? Absolutely. Will that have some time series data in it? Absolutely. But there's all of this immense amount of cost and toil that sits in the middle of this workflow that AI is absolutely going to disrupt.
Welcome back to Dev AI. I'm your host, Balaji Siva. This is a show where we talk with builders and thinkers shaping the future of software and AI. And AI has already changed how we write code. But what about the other 70% of engineering? The time is spent debugging, diagnosing, and firefighting. That's where today's guest comes in. I'm joined by Kyle Forster, founder of RunWhen, a company introducing a new concept called vibe troubleshooting. Applying Gen AI to the complex world of operational incident response. We'll be exploring what that means, how agents and automation fit in, and how this approach could change SRE and developer workflows alike. Kyle, thanks for joining us today. I know we had a long history, but I want you to do a quick intro about yourself to the audience.
Thank you so much for having me on. I appreciate this, and it is great to reconnect. So by way of intro, I started RunWhen after I left Google. So I was the head of product management for one of the kind of advanced Kubernetes services back there. And I got to see the world of Kubernetes adoption through the lens of a large number of our enterprise customers. A fascinating journey. Before then, I was a founder of a company called Big Switch Networks. This, back where Balaji and I met. A fantastic ride. We grew that from the very, very early days before there was even the name software-defined networking, through the wild times of defining the category, up to building that to about $70 million in sales before we were acquired by Arista. And then before that, a couple companies in Cisco was kind of the shared heritage, I think, frankly, of many of us in this space.
Absolutely. You talk about Cisco. I started in Cisco in troubleshooting customer networks. So this topic is actually dear to me. So like I was doing vibe troubleshooting like without, like long time ago when vibe troubleshooting, I guess the new concept here. All right, let's get into it. You have been talking about, vibe troubleshooting as a next logical step after vibe coding. What do you mean by that? Is it just a better search across alerts and runbooks? Are we talking about something more agentic and proactive?
So I think we're talking about two things. Certainly on the agentic and proactive side, we're talking first about autonomous troubleshooting. Okay, an alert comes in, and can you use agentic technologies as call it L1 first responder? And the answer is yes, absolutely. We're there. Can you use now this is sort of called the L1, L2 steps. And now things get a little bit more complicated, and clearly there needs to be a human who's got a lot more context. Can you give that person a great experience? The same experience that, I don't know how much you've used Cursor. I love using Cursor, frankly. I've tried a whole bunch of them. I love using a lot of them. But this idea that I can kind of go from concept to, wow, there were 200 lines of code in the last 10 seconds. And then there's another 500 lines of code. I kind of measure my cursor time now in thousands of lines of code per hour. It's just so powerful, and it's wonderful. Our vision for the product was not only the autonomous work, but then when you can bring it in front of a really senior person who really knows their systems in depth, and you can make that person feel like, wow, the system is doing a huge amount of work for me on a second-to-second basis. It's a really amazing feeling, and I think it brings troubleshooting very, very, very large-scale systems, that same feeling that you get from vibe coding of, I'd kind of know what could be done, and I'd give it a few instructions, and wow, it did everything that I would have done in a half an hour. It just did it very, very, very quickly.
Yeah.
And came back to me next. I love that.
You talked about, I think, a flow, maybe in this case, an alert going to an agent, and it's searching other alerts, past incidents, runbooks, triggering even automation, generating queries, and maybe summarizing to ticket. How does it differ from like what tools like Datadog or PagerDuty already offer today? How much of that you're sort of like moving the bar beyond that?
So I think, first of all, there's this category called AI SRE that's just starting to emerge. And I think there are kind of two sides to the category. One side is folks who are building AI assistants to query logs and metrics. There was this study that I saw on my last team that really, really influenced the early days of RunWhen. And it was that for 80% of Kubernetes alerts that required human interaction, 80% of those sessions wound up with the person going back on the kubectl CLI. That's an amazing number. 80% of the time, they couldn't get what they needed from all of the dashboards that were sitting right in front of them. The gargantuan amounts of money and time that's spent on these things, they still end up back on the CLI. So we actually use that as our starting point. And we said, all right, let's start from a human interacting with Kubernetes. And then we started growing our way down into cloud infrastructure. And then we started growing our way up into open source packages that are typically run. And then we started growing our way up into the application layer. Our largest customer is now, their first project was Kubernetes, but their largest second project is actually not Kubernetes at all. But I'd say the pattern still holds. Our goal was, let's emulate a human. Let's emulate a human on the CLI. Let's emulate a human checking metrics. Sure, checking logs, absolutely. But let's really emulate a human on the CLI interacting directly with their production systems.
Do you think that you're going to replace the dashboards? Like so you start with the dashboard, but you really can't do anything with it. I guess you're really ending up with the CLI. Like, do you expect to layer on your insights or agentic analysis right on the dashboard? Do you see that kind of a way of doing it? They still have the dashboard, but then you're, instead of just saying there's something wrong, you're essentially triaging and troubleshooting and giving you that solution right there. They can click and say, hey, let's do it.
I mean, I think 5 years from now, right, let's look at the workflow of an alert comes in, a lot of work happens, and it ends in either a person being able to do a fast remediation, or it ends up being a ticket for an application team to go take care of. If you define that as the workflow, today there's a lot of dashboards and a lot of human reasoning that goes in the middle of that workflow. A lot of it is high toil work. On average across the industry, we think that for every engineering ticket that's created, it costs about $500 to $700. We think that we can do that reasoning with an LLM plus a lot of automation technologies. It's not LLMs alone. And we think that comes out to about $5 to $7. So 1/100th of the cost. I do think if we look at a workflow this way, 5 years from now, dashboards are going to be looked at as something that's like a really expensive part of the middle. And did we really need it? I don't think so. I really don't. I think that, does the ticket for engineering, will that have pretty charts, pretty graphs? Absolutely. Will that have some time series data in it? Absolutely. But there's all of this immense amount of cost and toil that sits in the middle of this workflow that AI is absolutely going to disrupt.
Okay. But that's pretty bold, and I actually believe that. I want to ask you one thing. I think you talk many of the time you talk about an alert coming in, and obviously there's an agent reacting to it, and maybe sometimes resolving it automatically, or in some cases maybe giving you a sort of a, here's the potential next steps are, and what do you want to do, kind of a thing. Do you think the agent in the future maybe be proactive, like even before an alert sets it off, like something is trending down, and it can proactively do the research and say, hey, there's a deployment that went out last week, or sorry, an hour ago, that's causing something. So what do you think, and how is it different from, say, anomaly detection? Maybe you can talk about like future of how agent will do proactive sensing.
So I mean, we put our money where our mouth is on this one. We spent, almost a year developing an internal stack to say, hey, alerts that come, the common case alerts that come are very, something is already deeply wrong, and by far 99.9999% of the world, that's alerts coming in, and we need to respond to those. But we looked at what are the real best practices for how do you respond before something's wrong, and we came very convinced it's SLI threshold alerts as sort of one side, and then we keep on going to SLO error budget and SLO error burn budget. Other rating. It's chapter 6 of the Google SRE book, which we kind of believed. We sort of followed that one like the Bible. We build our automation stack to say, okay, we can take alerts in from existing observability tools, but let's take the absolute best in class approach. Let's take chapter 6 of the book. We build an internal stack that's capable of doing that installs entirely by default. So out of the box, a user gets the experience of error budget burn, triggering automation, which is kind of like what the best in the industry do. And can they get there in 5 minutes? That was a really, really important design principle for us. And we followed, we invested a massive amount of engineering into that one, 2023, just to make sure that we could get there.
So is RunWhen is an assistant that lives in the Slack, or what is the interface to the SRE? Like, how does it work?
So we have several because our users work across a number of interfaces. Fully autonomous, I just think of it as, hey, alerts are coming in and we're creating tickets. We're creating tickets in Jira, we're creating tickets in ServiceNow, we're creating GitHub issues. The slightly more human in the loop, okay, we need to start escalating, is almost always on the production side, Slack and Teams. So in Slack, it's a nifty Slack app that you go in and you can kind of do the very fast human loop. Hey, here's what we found. Hey, here's a remediation. I'm not certain enough. I need human approval before I run this. Okay, click. Fantastic. An interesting thing that we found in non-prod, we certainly have our own web UI when somebody wants a lot of detail, but in non-prod, we built a VS Code plugin. What we found is there's actually as much troubleshooting in non-prod as there is in production. It's slightly different people who do it, and they need different surfaces to do it in. So we said, could we create this agentic troubleshooting, vibe troubleshooting experience directly from VS Code? 100%. Are we working on MCP servers so that we can do it in Cursor? We already built one. I didn't want to release it until we're at V2. But can we bring the same experience to a developer saying, I don't think it's my code. I think it's something else.
I mean, you're getting into a topic which is like, is it just for SRE or is it just for developers? Right, that's what you're saying. Essentially, developers are able to, triage the issue themselves before doing other things.
Exactly.
Cool. And what signals does it consume? Like logs, metrics? I mean, how many systems are you observing, and is it a central deployment that is consuming all of that? Like, what's that central point that's actually doing that work of just, analyzing this thing?
So for us, it's a local agent running somewhere in a customer's infrastructure, and I think of that as it's the AI agent's laptop. So from that agent, we are querying metrics, we are querying logs, we are also directly interacting. We're running CLI commands that the user has approved in bulk. We're running REST queries, we're running SQL queries, anything that can be expressed in Bash or Python. We usually, because we have this big library now, we call it the public tools that come out by default. So by default, somebody gets all of the read-only tools and they can install our read-write tools and they can start building their own tools. Figure an installation on a small Kubernetes cluster generally comes up with 3 assistants up and running, kind of optimized for different tasks. You can add 4, 5, and 6. And across those 3 assistants, 2,000 to 3,000 tools for us on a default install is pretty normal. And then larger clusters will rapidly get up to 10, 11,000 tools. And then if you look at our really, really large production deployments, I think we have one that, as the build out goes over the next couple of months, it's going to be 172,000 tools.
Got it.
And I think it's required at real scale. I mean, you need these assistants to be capable of a vast number of different things before you actually deliver the value of real vibe troubleshooting. Otherwise, like a quarter of the job, and then back to the humans, it's not super. It's like when you're like AI coding, and then all of a sudden, like you need to do a lot of copy and paste. You're like, that kind of sucks.
Yeah. I wanted to maybe you can walk through a real world vibe troubleshooting example a little bit more. I know you touched upon a lot of the things already, but I want to see if I'm an SRE, let's say I'm an SRE on an e-commerce site, checkout success rate drops suddenly. The traditional workflow, I get an alert like after it hits the threshold. Like I open up a Grafana or Datadog, pull logs, look at the recent deploys, connect the dots manually. Obviously, it requires some sort of a senior engineer to even understand where to look. So in the RunWhen world, what happens, right? Does an agent alert me before I even notice? Does it build queries? Can you just walk me through that, the RunWhen scenario maybe?
Let me give you an example of one I was actually just on the call. It happened right before a team call. So I happened to be on it with 2 of our engineers. We were getting 500s from HTTP 500s from the front end in an unexpected way. And within about a minute, 2 minutes, maybe, we were into our UI to see, hey, is there anything recent that was done autonomously that we should take a look at? We actually found a couple of things that were done autonomously about 2 hours ago, but this had just started to happen. So we said, okay, this is something fresh. We started saying, all right, I'm getting 500s from the front end. What's going on here? It started by checking logs, and it started by checking Kubernetes deployment status, and then checked about warning events, error events. After about 3 or 4 minutes, it had probably done the equivalent of 200 or 300 kubectl CLI commands. It had probably done the equivalent of at least 10 API calls to different parts of our stack. We started troubleshooting through 5 different services, probably at like minute 5 or 6. 3 of those services written across 3 different languages, 2 of them running in totally separate Kubernetes clusters, because the way our sort of central system works out versus this system. We wound up sort of able to find the root cause, but then getting this really nice summary of, hey, what we saw was HTTP 500s on the front end. Here was the chain of thought, and then here was, we marked it. Okay, great, and here's the root cause, so that we could document this in case it shows up again, and so that we could feed it back into the assistant's knowledge. And obviously, you kind of know how LLMs work with memory. So this entire process, I mean, it was just beautiful, like watching a win in our system today.
Yeah, I mean, I can totally see how much time it probably saved you from having to troubleshoot through the traditional model. Kyle, RunWhen agents sounds very interesting. Can you show me some sort of the real examples of what some of the actions that RunWhen agents can perform?
Yeah, sure. Yeah, here we go. So you can kind of see the types of tools that these agents come armed with out of the box. There are a lot of them, and you can kind of see the different categories that we cover. So our goal is to cover low-level infrastructure, platform services, all the way up into popular language frameworks and even popular languages themselves. Certainly covering observability stacks, certainly covering other DevOps tools.
Is there a right way to understand, like, obviously this is the value add layer on top of LLM. LLM can maybe diagnose something, but then you have somebody has to take action, and you're really guiding the agent to perform these kind of complex tasks, particularly in something like going touching a Kubernetes cluster. You want to have a specific way, a methodology to do that. And is this sort of your way your agent actually does something? Is that the way I read it, right?
It's exactly the way to read it. Having LLMs generate this kind of work on the fly, it's possible, but it's not something. It's not a behavior that you'd want a human to do. You wouldn't tell a human, like, hey, please, like, generate a small batch script on the fly in the middle of an incident. Like, it's not such a hard idea. You want to be able to have these things be very, very repeatable, very reliable, and you don't want the vagaries of code generation as code generation gets better and better. But the thing that I actually worry about the most sometimes is argument generation. Anyways, a bit of an esoteric topic, but we also kind of care about RBAC. We care about verifiability. We care about repeatability. We care about, there's this kind of whole series of care abouts in large scale production. I think I mentioned our largest build out over the next couple of months is growing to 172,000 instances of these tools. At this kind of scale, if you were just using LLMs alone, it's certain that some things will be wrong often enough. So, the goal for us was using LLMs to choose the right tool rather than to create the tool by itself. And I think everybody in AI design is kind of coming to that conclusion. Like, AI is much more powerful when given tools rather than having the LLMs try to create the tools on the fly.
I totally get it, because for a large enterprise, they already know the best practice of doing things. You don't want a LLM to kind of hallucinate something in the middle of middle of the night. You want it to be as predictable as possible. When somebody says do this task, you want to know it's going to exactly do the one that you think it will be doing. This is a great little quick showcase of what your capabilities are. Thank you. All right, let's talk about MCP. I know you mentioned it briefly, right? You mentioned when RunWhen orchestrates a lot of observability and operational data. Do you feel like the RunWhen becomes into a platforms that other agents can query you, like almost like an MCP server for system state or troubleshooting state? The goal is to focus a system that integrates with your broader observability tools. What do you think about the trade-off in this case?
So the vision, I think, for this area that I feel deeply about and that I keep on hearing back from our users, I would say, interesting enough, it's changed a lot over the last year. A year ago was, hey, can I get ChatGPT for my stack? I think as our industry has become more and more mature about the way that we use AI, I don't think it's the, hey, can I get one really, really, really broad-based assistant? It's, hey, can I get called Pipeline Poly. I want Pipeline Poly to be proactive about any alert that's coming out of our CI/CD pipeline. And I want Pipeline Poly to be able to go through all of our CI/CD logs and figure out what's going on with that stage of the pipeline. I want Pipeline Poly to be able to either do a remediation or tell everybody, hey, this is just an interim step. The next job, I'll just do a retry. The next job will just be fine. And I want Pipeline Poly to also be able to answer any developers' questions so we avoid a stampede. Instead of, hey, I want ChatGPT covering everything, it's, hey, I want a very, very focused assistant here, and I want to turn every single person on my team from an individual contributor into a tech lead and manager. And I think that vision of how AI is going to get consumed in the enterprise has changed a lot in 12 months. And I think that this expectation kind of matched the very early vision that we put in with RunWhen. From day one, we had the sense of different agents with different personalities, with different scopes. So I feel like the market's kind of skating towards us in this regard. When you make these agents really, really powerful, right? When they're not only observability, but when they're also remediation, by scoping them down, you make them safer to use, you make them easier to use, you make them kind of more explainable. And I just think that's the direction the industry is headed for these agents that can really do stuff live. If I'm going to give an agent, in the consumer equivalent, if I'm going to give an agent my credit card, I want to know that that agent only has access to some e-commerce sites, not like anything that has an API.
Yeah, of course. Yeah, definitely. I work on the developer portal side, and I could totally see how the developer or anybody else sees some anomaly or something they want to investigate. They can just call you guys and be able to get the output or go fix it, and then that you can essentially be the fixer there. It's really an amazing potential use case where you essentially be another agent that we can call in, or the developer can call essentially to resolve issues. So that's great. So, well, with all the things you're talking about, what happens to the SRE? Is if this is gonna be the future, what's left for human people to do? I mean, of course, they have to approve some steps, but
I'm so convinced. I mean, I remember somebody telling me that, hey, garbage collection will be the end of developers. And that turned out to be like off by at least factor of 50. The sheer number of conversations that I have with directors and VPs, I'll give you one from last week. We need to do a migration from AWS to GCP. I have 5 people in my organization, and I desperately, desperately, desperately need them working on this. And all 5 of them are busy all day long, answering developers' questions, responding to alert, fighting fires. I can barely even get a meeting with all 5 of these people at one place in time before somebody has to walk out the door. How am I going to get this migration done? I mean, they're like maybe we hire a services firm to help us with the migration, or maybe we hire a services firm to help us backfill all this alert stuff in order to move people out over. And unfortunately, they were like kind of coming to the conclusion they might want need a services firm to do the more interesting part and the current people to do the more toilsome part, even though I think that that's like a million miles away from the optimal answer here. So I do think that the need for well-motivated, strong people in our industry is only going to go up. And I do think that as any individual can have more impact by being a tech lead manager of a team of 10 AI agents, the exact same thing we're seeing in small startups, those people will get paid more. I mean, no doubt about it, those people will get paid more, and probably a lot more. If you're a 3-person startup generating $8 million, $10 million of ARR right now, you're making a lot more than a 50-person startup generating $1 million of ARR. So the exact same thing is going to apply here that applies in these small startups that are very, very AI native.
yeah, I can totally see a future where the on-call becomes like an agent supervision than deep manual investigation. I'm sure they appreciate the 10 minutes, wake up and fix the issue, then sit for 3 hours in the middle of the night troubleshooting. I mean, that's probably may not be a bad idea to be there. Kyle, is there any other topic that you feel like we should talk about? Maybe you could, from your experience building RunWhen that you want to bring up here.
Appreciate the opportunity. One thing that we noticed early on is, can LLMs do it all? And I do think that at this stage, in about the landscape in general of using AI, certainly to build engineering tools, but I think AI tools in general, I think that what we'll see over the next year is the emergence of companies where it's no longer a light wrapper around LLMs. It's a lot of work that would be with a workflow that would be impossible without LLMs, but it still requires a lot of good taste and a lot of engineering design taste, and then a lot of blood, sweat, and tears, frankly, to this is infrastructure after all, at least on our side, to get something that really consistently works. So I think that what we'll see is these really interesting companies of, hey, this wouldn't have been possible without LLMs, but this is not the low-hanging fruit. This is the hard stuff. But we'll see some really, really amazing products out on called the AI tools landscape. I'm actually just as positive now about the future of AI tools as I was a year ago, maybe even more positive. But I think the nature of these are going to change quite a bit.
All right. Thanks, Kyle, for joining us today. It is always fun connecting with you again, and all the best for your success with RunWhen. Stick around for the final bite, my closing thoughts coming up next. Most engineers don't troubleshoot without a signal. We get paged and start connecting the dots. What vibe troubleshooting really promises is that the agent gets the vibe before we do. It picks up earlier anomalies, investigates across time series and logs, correlates context, and proposes a fix. It doesn't remove us from the loop, but it changes what the loop looks like. The future of troubleshooting isn't just faster dashboards, it's agentic diagnosis before damage, with a human in the loop for judgment. That's a real shift and maybe the real vibe.